Hi, I'm John from Unix Surplus, and today we're going to figure out how to get these NVMe drives into your Dell or any other servers and discuss how you can get performance PCIe IOPS in your computer. Disk drives started out using SAS RAID controllers that took a lot of disk drives that were very slow spinning drives and aggregated them into one. You had all sorts of things like batteries, SAS controllers, even little dongles for RAID license. Sometimes they were pretty simple. JBOD modes like this one didn't really have any intelligence or memory cache like these controllers do with their memory chips. But it was all tricks to accelerate disk drives. However, what we're finding now is that all this stuff into the PCIe buses is too slow. And all these chips right here are having so many pins, and all these pins here are just PCIe buses. So the natural thing is to take your SSD drives right here and attach them directly to the PCIe bus. That's what came out and was called NVMe. NVMe drives come in a few different formats. This here is what they call the U.2, which is designed to be a hot swap drive in the front of either server. It comes in different Dell brackets like this with different hot swap notches. However, it has some problems. A PCIe device legacy is normally always connected right into the CPU. It doesn't support hot swap very well. So sometimes they look at using SATA modes or other things. Other people then have come out with a newer format. This is an advanced enterprise one with a heatsink, but this is called M.2. M.2 has a few different lengths. This is another 110 millimeter Samsung. You can see that it has all these capacitors and extra big chips. This is what's underneath these heat-sinked enterprise modules. What this does, it allows you to have a memory cache with a controller and enough power on it to complete any write that's still waiting, just like you did with a disk drive. Similar to reasons that you would have with your RAID controller having batteries. So these are the new formats that are coming out, and we'll discuss those a little bit later here about M.2 and U.2 disk drives. So drives come to us in all sorts of ways, and I think it's always interesting to look at how they come. This one here is a single-sided, lower capacity enterprise Micron. It has disk drive features that aren't normally associated with it, like SAD or encryption. You can see the difference between the enterprise Samsungs being 110 and M.2 80. These are called 22110, and this smaller one here is called 2280. One thing I want to point out is that all these drives here, be it has a heatsink, it's an enterprise one, they also easily have adapters that come with each one. They can fit into PCIe buses. It's pretty simple. Each one of these drives has a PCIe X4. Even with the bracket, you can see it still fits into the adapter. They make them for all the different M.2 adapters. This one's called the Boss. It would fit in here, and you can adjust the length to whichever size drive you wanted to. This is the Dell boot card for NVMe. They all come into PCIe lanes. And those PCIe lanes can also travel through different cables. You can see this is a typical Dell cable here for PCIe. Blue, very low capacity, a little bit better connector, but you can see it looks just like a PCIe connector. This is a by 4 lane per cable. So let's take a look at the Dell R640. This is a great example of what was happening. In the day of the R630 or the Broadwell Skylake generation, people were putting these PCIe accelerators in that had a bunch of SSD drives for a very low latency controller all together in one large capacity drive. This one here is 1.6 terabytes. This is the Intel P series or P4660. You can always see the different part numbers on the other stuff too. Then Intel started to introduce the new formats. The new formats were designed to come in and be a hot swap replacement. And they had to use the same connectors that you already had for your existing backplanes. They had to be somewhat compatible and negotiate. They had to have SATA SAS modes. And that's where you came out with the U.2 format. This is a typical enterprise U.2. You can see that it has a big heat sink. Intel tries to do those big things to get higher temperature range and higher temperature range customers. Sometimes people are putting them in as just a SAS drive included. This one here is Toshiba. You can see Toshiba also goes for enterprise customers with a big heatsink on the controller. All extended temperature range products. In fact, we can even show you a Samsung as well. Samsung doesn't care. They just got the lowest power because they got the best fab. So let's go back to the R640. The R640, in order to get these PCIe lanes into here, already used Skylake CPUs. What that means that these guys, Intel decided to take some of their pins and be inter-CPU communication. And that was done so you could do shared memory, larger caches per CPU, so each drive could have larger stuff. That's always called what Intel calls QPI, or Quad Processor Interconnect. Even though it's 2 processor, it was designed to be up to 4. So when you're looking at the Skylake CPUs, and then later on the Kaby Lake and Ice Lake, this design here really has a lot of interconnect here going when you came up with like the platinum level marketing. So they didn't have very many slots. So you either had a choice, you could use what you had for PCIe lanes, but then customers still wanted the old SAS options. So you still had to have your old SAS controller available here and your SAS expander backplane, but they needed to make something totally compatible. So what they did is they used cables that they already had. This is the H330. You can see the heat sinks on it. It's a very high performance 12 gigasecond SAS3 JBOD controller. But then they came out with what Broadcom, used to be LSI Avago, is coming out, where it has dual mode controllers. Not only does it have the SAS3 connectors, but it also supports PCIe and NVMe. You need to use this controller because you also still need to talk to your current backplane, which was SAS3. So to do that, you took 64 bits of PCIe and you would put it in your PCIe channel, and you would install all your cables in here, all the way around your CPUs, to go and give you up to 4 NVMe drives inside a Dell R640. And that's how Dell had to kind of put all the tomatoes into the can. The other way they did it very quite simply, and you can still see this whenever you shop at Dell, was they came up with a boss card. The boss card is simpler, elegant, fits in anything. That uses all of the different smaller M.2 cards. So you can easily slip inside here your little notched card here. Sometimes you can even buy them with enterprise heat sinks too, if you're Facebook, etc., and you're gonna run these streaming. And it just quickly plugs right in here. One of the problems too is the design of the original architecture and BIOS is how to boot. So typically all these cards here still boot out of SATA mode. So you'll find that in order to boot off of these things, you're going to have to connect to SATA mode in the BIOS, which will then allow you to use the SATA port, which is the old legacy, to come up and boot. Still, they haven't been able to fix it except in the newer generations of architecture to boot off of a PCIe device and truly map it to that old port 80 that you would go with an MFM hard drive. So that's a review of how Dell is doing it in the R640 system here. So enter in AMD on the scene. And what they came up with is a way to revolutionize again, just like they did with the Opteron, becoming a 2-core CPU. What they did here is they said, well, we don't need all that QPI. We can go to TSMC, who has a little bit better process and can do things a little bit more efficiently. And instead of making all these different CPUs, we can connect all these PCIe devices and all of our partners can join in instead of just Intel having that one thing. So what they decided to do was a single CPU, the EPYC. You can also have it in dual things. They're PCIe lane interconnected. When then you get all these extra lanes. So you get a 64-bit slot right here for hooking up your 100 gig networking card. You get another 64-bit, 8-lane slot, right? 16-lane slot here. You get here your SAS controller perk. You get your internal devices down here, your TPM, all that stuff on PCIe lanes. This thing right here has 128 PCIe lanes coming in and out, and memory. So what does that give you? It gives you all these connectors here. And what are they going to do with that? They're going to hook up storage. So they're going to take this memory here and make it almost as fast as all of your regular storage that you're using in your drives by hooking up with the low latency, low access PCIe NVMe lanes. So this is a new generation. And what are you seeing now? Well, you're seeing whole servers based on this with these enterprise drives, up to 50 of them in front with a PCIe bridge chip, similar to that SAS bridge. This particular system here is the economical machine because you don't need any bridge chips or that. You just need one AMD Opteron CPU. You don't have very many expensive support slots, and you can get 10 hot swap drives in the front. If the drives are at 8 terabytes each, and they're so fast that you don't need RAID, you get 80 terabytes into this one particular machine, fill it up with 64 gig DIMMs, or 128s even, you're already at 2 terabytes running here in this one machine to this one CPU with 64 cores. So you're getting all this package with one CPU, 200 watts, at half the power as you would get from an Intel machine. And that's why people are going to AMD EPYC. But it's a very different design where you can see that everything has a PCIe connector, PCIe, and all these lanes are coming straight out to the backplane here so that you can do NVMe or PCIe attached storage. So you're taking the CPU core to the CPU core cache to the DRAM memory to the drives is almost one latency. So let's take a little time to talk about who does what and why. So you have a lot of different companies involved in here. You have Dell EMC. They're a real stuffy Bostonian company like CDC or something like that that used to make hard drives. We need to do everything right. We need to have all the details. We need to have high quality. But they're also American, so their quality support is really outsourced over to Southeast Asia. Then you have companies here like Toshiba. Toshiba is now Kyocera, and they're a Japanese company. They've always made their money falling on their sword for quality. If we make a mistake, we will eat it and tell you. They're some of the highest quality products. You have companies out there like Samsung. Samsung's basically a process and fab memory company. They just want to make chips and they want to optimize their design and optimize their process. Look at how much less heat sink they need because their voltage and their layers and their density is so much better controlled because they control their engineering process. Then you have companies like Intel. Intel needs to make a spec that works for everybody with high temperature ranges, a mil spec level of drive, that they don't care. They're going to be the enterprise customer and they're going to be the reference design because they need to have those drives to work with these CPUs with all these PCIe spins. And they need to release it quick and early at the beginning of the things. And it's also very, very telling that companies like Intel are now in Roseville where they do the storage. Guess where Toshiba's at? Right next door. They're hiring all their engineers. It's the same level of technology. Only Samsung is over here in Silicon Valley still, and they have all their engineering here. But Samsung's a very diverse company with a lot of different technologies. So that's kind of a roundup of different people and why they do different things. So let's take a look more at blades, and you'll see those differences between Supermicro and Dell. So let's go over some of those manufacturers again. This here is the new technology that Facebook's using. They decided to go with Kyocera or Toshiba, a Japanese company, with all these capacitors, all these big chips here for the highest quality product because Facebook knows they're going to grind this NVMe drive into dust and they're going to beat it up with all those IOPS AI effects. Where you take a look at Samsung, yeah, they still got a little bit more power efficiency, so they don't need as many power capacitors over there. They got a good controller, so a few less chips than what Toshiba needs over there. Toshiba, to make a 2 terabyte, has 1, 2, 3, 4, 5, 6 large chips, whereas Samsung can do it only in 4. So those are the differences. Then you have innovative little Taiwanese companies. This is Inadesk. They're making a niche product that's a little M.2 that goes in a tiny little capacity. So you can fit it in the tiniest little areas. And they invented the boot disk and the SATA DOM. So this is one of their tiny products right now for NVMe. A little note about all these different drives. If you take a look at them, there's differences. These are the enterprise drives, and they have 2 notches. Here, just one here, 1 notch, 2 sections. You find 3 sections over here. The 3rd section is proof that it'll also work in SATA mode, right here. So you can see the differences in the M.2 boot notching, and these are PCIe only mode, and these here are SATA and PCIe. So let's take a look at a few blade servers and how they're getting NVMe in there. In fact, you're not going to get NVMe very many ways. Right now, you have the M640 Blade here. This uses 2 Intel Skylakes. You can feel this thing is about 5 pounds of heatsink just right here. They had to put so much copper in there to be able to take those heats between the 2 CPUs lined right on up. This thing has a few options. You have a card that goes right over here that's their version of the M.2 boss card that'll take your M.2 boots. You also have options that come in here, and these are your PCIe slot versions. And this is the M640. What this does is it has a simple connection to the front here for your front mount NVMe drives. And you'll be able to slide these right in here and mount a Dell hard drive right here to the NVMe only black one. And that's the M640. And this is another indicative thing of how Supermicro does it, which is a little bit different. Supermicro does it in a little bit more modular system, so you can have your different components installed. You're going to have your risers right here determine whether or not you have your M.2 options. So you'd be able to fit an M.2 80, or remember that tiny little card? Well, you can fit it in backwards right here, and you can have redundant boot. Thank you, Innodesk. And they're here. This is a simple modular system where they have a single card for a networking option. They still have your PCIe slot card, so you can buy whatever card you want to have there. But sometimes you give up your PCIe slots. This one even gives it up for a SATA mode boot, so that you can come into your SATA ports on your Blade, and you can boot off of SATA. Your Nutanix needed that. Sometimes it's just over here with a lot of power here, and you have an inductor noise choke right here, and this will allow you to have two M.2. And of course, it's real simple stuff. They put BPN, backplane adapter, ADP adapter, to M.2, 1U. So this is for a 1U blade, 1UB, for 2 M.2. And you can see the little differences. The Supermicro just uses simple folded steel. Dell manufactures over at Quanta, so they have these complicated rails on everything that they would do for their blades, and a complicated connector, whereas Supermicro just has everything going to the hard drives here, and then the power comes in through a simple edge connector right there too. And this is a little bit about the differences between the Bostonian, we need to have the biggest quality because we're going to sell to a bank, and Supermicro, who says we want to have it simple so we can manufacture it, have it all in stock. And these modular heatsink choices are the same for our 1U servers, and our modular cards are the same across all of our blades. All we do is have a few different pieces here to change out. And guess what? You can get your server within 30 days, whereas Dell, you might have to wait a year. So we went over a lot of different NVMe options. We discovered that newer systems like the AMD EPYC have this designed in. In fact, even the PCIe generation comes to be a factor. PCIe 3.0 has so much bandwidth, whereas PCIe 4.0 is going to have this bandwidth. And then the new servers called Rome or Milan all support into the new PCIe 4.0 standards, which gives you a little bit more bandwidth per disk drive coming in and out. We talked about some simpler adapters that you can just put in. This is a simple little X16 adapter that just holds itself in there. You don't even need any screws to mount a M.2. We talked about the different formats when you have the ones that go in and out and are like a 2.5-inch hard drive U.2, even some of the PCIe cards that were made classically. And then we have the different size formats from 22 by 110, 2280, 2260 to fit in your Intel NUC. These are all the different M.2 formats. We talked a little bit about notching and how that's different between two different drives, and if you can have a single or double notch, if you support SATA mode at all. We talked about legacy boot. If you're using older CPUs, you probably want to boot off of a SATA device first. It just works and it's simple, and it'll work when your BIOS is all cranked up and messed up and you're really far away. So let's boot off that. You've got some of the different adapters, like this is the Boss card from Dell. Not much different than this Super Chinese card right here. Yeah, do you really need any more components than this? Well, Dell thinks they need a capacitor, a noise choke, some more resistors over here, and a couple little ICs to transfer SATA mode through it. Not really complicated. Some people think you don't need any components at all. Difference in simplicity of design. And we talked about really what you need to do is the newer generations if you want to support NVMe, because it's worthwhile to step up to the current price per core versus the older machines. But let's talk about you, the end user. What are you going to want to do? You're going to want to put an inexpensive drive in your PC. And the best way to do that is to go buy a surplus server drive that's in U.2 format, put it on a $10 adapter, hook up your SATA cable if you need to boot it off of SATA, and put it in that gaming PC. So you get all the same IOPS performance off of a 1 terabyte design designed to go into one of these huge enterprise servers that everybody's engineering for at the super low cost. And that's the way to get capacity on your gaming PC or your PC at home for under $100. So thanks for watching our video here at Unix Surplus. Our goal is to get these NVMe drives that we just bought 4,000 surplus from Lenovo into your hands.
You can reach us at 877 Unix 123.
Or check out any of the links down below in this video. We got some great sales and some promotions going on. We're really excited here in the Golden State because we just won the NBA championships again. It feels great to win, but we wanted to share some of that love with you. So we came out with the Golden State Surplus Servers t-shirt. If you're a geek, you'll get that you got your hard drives here just like a RAID and all your exclusive XORs, and you'll be styling like Klay Thompson and Stephen Curry.
Go to unixsurplus.com/promotions to get your free t-shirt with the purchase.
So thanks for watching our video here at Unix Surplus.